Hi there, all you dental hygiene students. I know that this video is being made for one person in particular, but I know it's going to make the rounds. So once I put it out there on the internet, I'm just going to leave it open for anybody that wants to take a look at this. Okay, I know that some people are not as strong in mathematical calculations. This video is for you. Now, before I begin this, I am going to put a link down in the YouTube section down there. The method that I'm going to use in this video for doing these calculations is called dimensional analysis. So if you're not familiar with dimensional analysis, I want you to go and look at that video first. There's all kinds of videos on the internet, but look at the one that I made, because of course mine's the best. And I want you to look at this process that I'm using to cancel out units in the calculations. It should make what I'm going to be presenting here make more sense. All right? Let's get started. Now, you guys know that I'm an engineer and I'm not a dental hygienist, so I had to do a little research before I put all of this together, so that I understood what you guys are learning. And here's what I figured out. On all of these medicines, and this is just, I guess, a standard list of medicines that I actually pulled off the internet. Each one of these medicines has a percentage of the agent that's in the solution. So the first thing that I learned was this concentration of local anesthetic. Of each one of these drugs that are in the solution, if you have a 1% solution, that's the same as having 10 milligrams of the drug in every milliliter. And 2% means you've got 20 grams per milliliter. And 3% means you've got 30 milligrams per liter. 4% means you have 40 milligrams per milliliter. So what they're doing is they're taking each one of these percentages and multiplying by 10. So if you have a 0.5%, which is on this drug right here, if you multiply that by 10, that becomes 5 milligrams per milliliter. Now that's something that's very easy to memorize. So this right here, I would have that memorized, because you just take your percentages, like that right there becomes 20 milligrams per milliliter. That's 30 milligrams per milliliter. That's I don't know if that number is right or not. That you guys can check that. That's 20 milligrams per milliliter. This is going to be 5 milligrams of that drug per milliliter. 40 milligrams per milliliter, 40 milligrams per milliliter, and 40 milligrams per milliliter. So that's pretty easy to memorize, I think. I would memorize that so you don't have to actually do the calculation. Okay, the other thing I learned is I had to go look up what a carpule was. A carpule is the same as a cartridge. And I noticed in your calculations, sometimes they were using 1.7 milliliters as the capacity per each carp. In some of the calculations, it was 1.8 milliliters per carp. And so what Michelle told me was that the manufacturer says, well, it's 1.76 or 78, which rounds up to 1.8. So I guess that's the standard number to use. In these problems I'm going to give you, you just have to look to see which one of these they want you to use. But it sounds like using 1.8 is pretty standard if nobody's giving you any instructions. Okay, one thing that didn't get copied over is this right here is maximum dose for each one of these drugs. That's the maximum dose. This was what I guess you're using in your program, or it's what's being used in your textbook. I don't know which. They're a little bit different than what I pulled off the internet. Of course, what I pulled off the internet might have been old numbers. Okay? This right here, that is the recommended dose per pound, which again was a little bit different than what I pulled off the internet. I guess this is coming out of your textbook or from your instructors. This number right here, that's definitely something. I think the more you work with these numbers, you're just going to memorize it. It will be memorized. All of this down in here, these are fixed numbers, but you can calculate it. For this 2% lidocaine, that's going to be 20 milligrams per liter multiplied by this number right here. And I'm going to show you in the calculations. So none of this down here you have to memorize because you can calculate it. Okay? So let me clean this up. And if anybody wants a copy of this right here, I'll see if I can't make that available to you. Okay? Let's start with our first problem. The first problem says, how many milligrams of a local anesthetic agent are there in 4 carpules, 1.7 milliliter, of 4% prilocaine? All right, so when I looked at this problem here, the first thing I went to was this. All right, I know that 4% means I'm going to multiply that by 10. 4% prilocaine means that there's 40 milligrams in every milliliter. So that was a number that was given to me. That's one of my givens. I also noticed that they told me I have 4 carps. Okay, so I'm going to be like you girls. I'm going to abbreviate that. I have 4 carps, and they're telling me to use a conversion factor of 1.7 milliliters for each carp. Okay? This is what I'm trying to calculate. Let me highlight it. I'm trying to figure out how many milligrams of this anesthetic agent is in these 4 carps. All right? So what I'm going to do, and I hope you watch that dimensional analysis video. This will make a whole lot more sense. My goal is milligrams. So I'm going to write this here. I'm going to write this on a line. The line represents a fraction bar. Now don't freak out. I know people hate fractions, but this isn't going to hurt. I'm going to start off with this 40 milligrams per milliliter. I didn't know really where to start, so I started my calculations there. Because, I mean, it's 4%. So that's 40 milligrams in 1 milliliter, okay? And what I did was I just created a ratio or a fraction on that line. And I'm going to do this just to separate each one of these components, and I'll show you why in a minute. So I've used this number in my calculation. Now, I'm going to go ahead and use this one next. The capacity in a cartridge, there's 1.7 milliliters in 1 carp. So I'm going to write it like that. Okay, there's 1.7 milliliters in a carp. Now, with dimensional analysis, if you watch my video, and I highly recommend it, a milliliter in the denominator of this fraction, and this is a fraction, 40 over 1. This is a fraction, 1.7 over 1. The milliliters in the denominator cancel out with the milliliters in the numerator. If I multiplied the 40 by the 1.7, I'm going to have milligrams per 1 carp. Okay, that's going to give you how much medicine in 1 carp. But they told us we have 4 carps. So here's the next step. I have 4 carps. Now, the unit of carp in the denominator cancels out with the carp in the numerator. And if you want to, you can put a 1 in the denominator on this fraction. Okay? 1 in the denominator disappears. It's invisible. What I'm left with is, okay, the milliliters canceled out, the carps canceled out, and I'm left with units of milligram, and that was my goal. So now what we're going to do is we're going to multiply these fractions together. When you multiply fractions together, it's numerator times numerator times numerator over denominator times denominator times denominator. So it looks like this. I have 40 in the numerator, multiplied by 1.7 in the numerator, multiplied by 4 in the numerator, and guess what? In the denominator, I have 1 times 1 times 1. Anytime, we all know that 1 times 1 times 1 turns out to be 1. So let me just go ahead and simplify that. Get my pen. And anytime you have a number over 1, for instance, like 5 over 1, use your calculator. What's 5 divided by 1? Yeah, you get 5. What's 10 over 1? You get 10. Your denominator of 1 goes invisible. So what I can do is I can just do this, and I'm going to be multiplying these three numbers together. So when I did that, I got 272, and what's the units? Yeah, milligrams of what? This stuff here. 4% prilocaine. Okay? Let's try another one. Let's try another problem. Okay, on this one, how many milligrams of a local anesthetic agent are present in, I think that was supposed to be 1.7, that's a little typo, 1.7 milliliter cartridge of 2% xylocaine. Okay, well, I'm going to start, let me go ahead and paste this in here and drag that down because I know I'm going to want to use that. So I like to list out what all my givens were first. I was given this 2%. Well, how do you change that to milligrams per milliliter? You multiply by 10. I have 10 milligrams per 1 milliliter of this drug. That was an easy calculation to do in your head. They told me this. I have 1.7 milliliters in 1 carp. They want to know how many milliliters of this anesthetic agent are present in a 1.7 milliliter carp of 2% xylocaine. Well, this is pretty short. My goal is milligrams. So I'm going to put that as my goal over here. My given, I'm going to start with this guy here, the 2%, which has been changed to 20 milligrams of the drug in 1 milliliter solution. The next number I have is the 1.7. I want to be left with milligrams in my numerator. I got to get rid of milliliters, so milliliters down here cancels out with milliliters up here. I want my milliliters here. Well, that's 1.7 milliliters in 1 carp. The milliliters here cancels out with milliliters here, and I'm going to be left actually with milligrams per 1 carp. So let's put a carp down here. So that's telling me I need to take 20 times 1.7. In the denominator, 1 times 1 is just 1, and that goes invisible. It's 20 times 1.7, which, let me look at my calculations here, gives me 34 milligrams per carp of, I need to finish this out, 2% xylocaine, which isn't that lidocaine? See, I'm learning something here too. And I want to show you something before I go on. That 34 milligrams per carp, if we go back to that original table right here, for xylocaine, well, I'm using a different number here. I was using the 1.8. If I had used 1.7 here, I would have gotten the 34 here. You don't have to memorize these numbers because you can calculate them.